Good evening, everyone, and welcome to Zoom into Physics. Let me first start by acknowledging the traditional custodians of the land on which we're all meeting. For me, in DY in Sydney, it's the Darug Nation, and I pay my respects to their elders, past, present, and emerging. Zoom into Physics is brought to you by the Australian Institute of Physics. The role of the AIP is promoting the role of physics in research, education, industry, and the community. And this is one of the very many things that that we do in AIP. And if you want to check out more things, either visit us on Facebook, on LinkedIn, our webpage, or on Meetup. Tonight, we've got a very, very interesting topic. Physics has a lot to say about many aspects of life. Life, the universe, and everything, in fact. But what, if anything, is outside the scope of scientific method? And what I mean by this is if we look back over centuries of science, there are a couple of examples for illustration. For example, Galileo was not afraid to challenge the prevailing acceptance that the Earth was the center of the universe. His theory was considered heretical at the time, but of course it was perfectly correct. I read that Ludwig Boltzmann was a big proponent of the existence of atoms when that model was still very controversial, and even his supporters, who originally sided with him, gradually distanced themselves from that model when the work seemingly undermined previously accepted and understood laws of physics. And tragically, in his case, Boltzmann, who most likely suffered from bipolar disorder, actually hanged himself as a result. And then more recently, in 1989, Fleischmann and Pons claimed evidence of cold fusion, and something that very tantalizingly offered a solution to all our future energy needs. Their claims were ultimately withdrawn, but not before many scientists and even school students got onto that bandwagon, attempting to replicate the work, and even several groups claimed to have observed excess heat produced from the experiments. And I think that if we look back, the most remarkable thing of all of that was that the fervor with which the different camps sort of fought their corners, and the extent to which it became quite non-scientific and very emotional. And then we'll look at a little bit about the way we decide how science is conducted these days, relying on funding bodies, assessed by peers, scientific metrics, perhaps, and how that influences what science people choose to do, and how that controls the whole science community, and we'll get into that and discuss whether resources should be going to other things, and whether there are artificial constraints that we shouldn't really place on science. The panel always has a bit of a chat going on in the weeks leading up to these events, and to explore topics and discuss what might be interesting, what definitely isn't interesting. And I think it's fair to say that this time we had the widest spectrum of opinions on things. So I think tonight it really could go anywhere, and I think it's going to be really good fun. Let me say a little bit about how it works for those who haven't been here before. We will finish around 9:30, but how we spend our time between now and 9:30 is really up to us, as long as we sort of stay reasonably on target on the topic. We really welcome participation from anyone and everyone, and you can do that in two ways. Simply unmute your microphone and pitch in. Just remain courteous and polite, and probably mute yourself when you're not talking and just listening. There's usually a bit of a chat thing going on the sidelines, So feel free to post comments and questions down there, and all the panelists and everyone sort of keeps an eye on that as we go forwards. The other thing I'd just like to say is that the views that are expressed by us this evening are our own personal views. They're not necessarily representative of our employers. This might be a bit of a controversial topic, I think, but it is a topic of genuine inquiry, and we're not setting out or intending to cause any offense to anyone. So please, we might get into some territory there. So let's be aware of that. It's certainly acceptable for you to enjoy drinks and nibbles, and even cuddle a cat if that's your thing. So without further ado, I will introduce our panel to you today, or get them to introduce themselves, in fact. And we always do that by asking them to talk a little bit about themselves, and then to answer an introductory question. And the question for this evening is there a phenomenon that is not currently the subject of scientific exploration and you think it should be? And so I'll start off in reverse order this month, and introduce our special guest tonight. Our special guest is Professor Dean Rickles. He is the Professor of History and Philosophy of Modern Physics at Sydney University, and also, very interestingly, the co-director of the Centre for Time. So, Dean, please introduce yourself to us, please.
Well, this is my first time at this Zoom into Physics show, so I'm not sure how long I should speak for now and what I'm saying, but my main field is philosophy of physics. I trained in physics originally. I'm now Professor of History and Philosophy of Physics, and I like to basically draw lessons, historical lessons from the physics, and apply them to the philosophy, and apply the philosophy to the history of the physics as well. And I mainly work on space-time physics, especially quantum gravity, and especially string theory. And I've written a couple of recent histories on these. There's a recent one for Oxford University Press on the history of quantum gravity in the early days, and also a history of string theory from its beginnings until roughly the 1995. In terms of, is there anything that isn't studied by science that really should be? Mostly controversial things, and that's probably why you started the way you did when you when you just introduced things there. There are a lot of controversial things out there at the moment. I think there's a lot of fear that people have about speaking about certain issues because of the community's responses that they expect if they discuss it, and it's actually well-founded, I think. I'm thinking in particular of things like gender issues, and maybe COVID response strategy issues, even the extent to which, for example, lockdowns are scientifically legitimate means of controlling public health problems like pandemics. We don't have many examples in the past. We can't really replicate them. We have only this recent experience with lockdowns. So I think we should probably try and remove a lot of the political taint that a lot of these issues have, but obviously that's very, very, very hard to do. And I think possibly also, I will finish it in a second, but I think also a lot of the controversy happens mainly on social media, and I think it stirs it up a lot more than it really is in reality. I think if you're on Twitter, it looks like there's just a firestorm after anybody says anything. If you don't look at Twitter, then it's not quite so crazy as all that. So that would be my response to that question, I think.
Thank you, Dean, and welcome, and thank you very much for attending tonight. Let me move on to our regular panel, and can I kick off with you, Kirrily?
Yeah, sure. So hi, I'm Dr. Kiriley Rule. I am the Honorary National Secretary of the Australian Institute of Physics. So that's how I got involved with this gig for the AIP. But I'm also an experimental physicist, and I work at ANSTO. You can see the core of the ANSTO reactor sitting behind me tonight. So this is quite an interesting topic, and I loved doing some research looking into pseudoscience and metaphysics and what we can accept, what we can't accept. And I think that Dean raised some valid points when he said that, you know, our experiences with COVID and lockdown and all these new experiences we are discovering through this pandemic is really asking a lot more questions than we have answers to. So I think when I thought about the question, you know, is there a phenomenon that we need to know more about and more about scientifically, I would hit that at mental health. You know, I know a lot of people that have suffered from sort of mental health issues. And even now there's still a stigma about, oh, well, you know, you're not really sick if you're having a mental, you know, a mental crisis or a mental health day. You know, that's not as accepted as if you've got a cold and you need to take a day off for that. You know, I mean, I'm sure scientifically we've come a long way from, you know, performing frontal lobotomies and electrocution. But I still think that there's a lot that we don't know just how to handle or how to support people with mental health issues. So I think, you know, it's like there's no one right answer for everybody. And I think that's what's so difficult about mental health, is that each individual has their own needs, and it's really difficult to put a sort of a scientific nail on that. So yeah, that's what I would say.
Thank you, Kirrily. Geraint.
Hi there. Yes, so I'm Geraint. I'm a professor of astrophysics at the University of Sydney. I do a lot of theoretical work and also observational work in trying to study the universe. My focus is on the dark side of the universe, something we've talked about recently, which is, you know, the dark matter and dark energy that dominates the cosmos. With regard to the question, look, I did, you know, grind my mental gears over this. I want to reflect what Kirrily said, is that I do worry that there's a lot of issues in medical science which I don't see being fully based in terms of what we would call modern science. There's an awful lot of stuff which is, you know, handed down from the practitioners from above, and it's just taken as this sort of medical advice, and it's not much more than sort of old wives' tales. Rather than going down that road, though, I'm going to sort of tell you something that I've been thinking about recently. In science, like, we have this saying that, you know, that the plural of anecdote is not data, is that, you know, people just saying things are not really adding to the scientific discourse, right? And it's not data if it's just some story here or there. But I've been reading a lot of history recently, and there's a lot of history out there which I think is somewhere in the soft social sciences and actually has impact on our long-term picture of human evolution, right? So, you know, stories that we sometimes learn from like Bible school about the flood, and you realize lots of people have got stories of floods in their sort of creation myths. And are these based in any kind of fact that tells us something about the life of the earth and the civilization and the world that we evolved in? And I think there's still a very sort of soft boundary between what we consider hard history and the soft social science pictures of, you know, the myths that we have attached to that. So I'm hoping that maybe that will become more scientific in the future. The stories that we have are somehow related to things that we experienced.
Thank you, Geraint. And lastly, over to you, Tibor.
Thank you, Scott, and good evening, everyone. My name is Tibor. The name is Hungarian. I'm an honorary associate of the Department of Philosophy at Sydney University, and some people think I'm a philosopher of science. The things that interest me, the things that I think science could be studying that they don't seem to be studying, There's one area which is the complex systems dynamics of the physical domain, which seems to be overlooked in some areas of science, mostly perhaps in chemistry and biology. I think there's a lot of interesting stuff that comes out of complex dynamics. And I think there's also a lot of interesting stuff that happens at the human interface of science. Why do humans do science the way they do science? Why do we think the world is the way the world is? And what are the limitations that being human imposes upon our understanding of science? I think there's some areas of self-reference in there that we can sort out as well. So there's lots of interesting stuff that I think lends itself to a deeper scientific inquiry.
Thank you, Tibor. And I think all of those responses were surprisingly sensible. I think if I was answering that question, I'd gone a bit, I'm very interested in ghosts and UFOs. I used to love that stuff when I was a kid. I had this book called something about the unexplained, and I just love that stuff. And you know, it's all out there. And
so Scott, let me just add, I think that book you're talking about, The Unexplained, was written by Arthur C. Clarke.
Yeah, it was. That's right. That's
yeah, who is a famous scientist and also a famous science fiction writer, and also dabbled in that area.
Yeah, absolutely. Why don't, if anyone else has on the call has an area that they think should be part of scientific exploration but isn't, just pop it in the chat. Let's start off the way that we always love to start, with definitions, and we're talking about the boundaries of physics. So let's start with what is physics and what isn't physics, and has the scope of physics changed since we've rigidly disciplinized it, as it were. So who would like to kick off with an attempt at that one?
I could have a go. I mean, so you mentioned ghosts earlier. I mean, here's a surprising example. So Lodge, the physicist Lodge, who was an ether theorist in the early part of the last century, also was heavily into the occult. There was a whole bunch of scientists, like serious scientists. William James was another, who were very, very heavily into the notion of the occult, the idea that you could have clairvoyance. They used to go to seances and try and figure all of these things out. At that time, they had no idea whether these were belong to the realm of pseudoscience, belong to the realm of science or not. So, I mean, so there's one extreme shift that happened very, very quickly. On the definition of physics, the only definition that I like is by a physicist turned philosopher of physics called James Cushing, who used to work on strong interaction physics, and then he switched. Basically, he says that physics is whatever physicists do.
Mm-hmm.
And that's about as much as you can say, because it shifts too often in order to pin it down with a set of sufficient and necessary conditions. And if you do try and pin it down with necessary and sufficient conditions, you end up with counterexamples all over the place of things that you don't want to be physics or science being counting as science, and things that you want to be science not counting as science and physics.
Dean, that raises a question for me. Can we narrow it down by trying to define or to limit or describe what physics is about? Not what they do and what physicists do and how they go about it, but is there a domain that physics addresses? Is it the physical world, or is it something about the spatio-temporal three-dimensional space that we think we live in? Is there a way of narrowing it down and say, well, if it's not about that, then it's not physics?
You could try and narrow it down, and people have, but once again, as soon as you try and narrow it down, you face counterexamples. So you might say, some people, Percy Bridgman, for example, would say, look, it's just about readings on dials on instruments in labs. But then you've got Ernst Mach, who says it's actually not about physical world at all. It's about our perceptions, our phenomena, the phenomenology of looking at the world. Then you've got Bohr, who say something like it's about what's publicly observable, what can be communicated in a classical language. So it just varies far too widely in order to pin it down, I think, in any way in those terms.
I think you've hit on a really good point there, Dean. It's observation. You know, how are you convinced that something is a law of physics or that something exists? You know, what observation do you need? How do we observe something? You know, I study atoms on a daily basis, but I can't see them. I need to rely on the instrumentation, you know, the dials, like you said, to tell me what's going on an atomic scale. So, you know, observation, when it comes to physics, perhaps observation is something that we also need to define. What do you believe?
Yeah, I mean, so the problem with observation is that it also involves a hell of a lot of inference as well. I mean, look, think of Newton's absolute space, for example. Nobody observes absolute space. What you observe are motions, and there are certain motions that shouldn't be there unless there is absolute space, like absolute motions, right? Like inertial effects, like feeling the push of an airplane on your back and things like that. So that's not observed, but it's an inference from what is observed in that case. So you'd have to sort of go a little bit beyond just observations. They're sort of a ground, they're obviously a ground in physics especially, but there's additional elements that you also need to introduce, I think, in order to make sense of those observations.
Absolutely, and I think the level of observation changes with time as our instrumentation and inference can get better. If I draw it back to what Scott said at the beginning, you know, for example, looking at the supernatural, UFOs, you know, you look back at the 1950s and you look at some sort of grainy photographs, and that was proof that UFOs existed. But, you know, with Photoshop out there, you could get the best photo ever, but who would really believe it nowadays? So again, you know, as your instrumentation changes, your belief perhaps also must change.
And where does that leave something like parallel universe theories or hypotheses? Is that called physics? Now, that's something that can't be observed in principle.
Can I just jump in again here and just go back to the point we had before we started the conversation, is that as physicists, none of us were told what physics is, right? We all came into this, we had our physics education. And I think if you asked a room full of physicists what physics is, you will get, you know, 500 different answers, because it depends on what your view of your area of physics is. And so to some people, the notion of a parallel universe is something, look, it's mathematical at the moment, but it's just out there. And to the other side of physics, it's just wacky, crazy X-Files stuff. So I don't think there's a single viewpoint across the notion of physics, of what even physics is.
But I mean, I think Kirrily is right, because even across all those 500 definitions, in the end, it must lead to something that's observable, something. Even if the many worlds are not observable at the time, they must imply something that is observable, that makes them true, that makes you believe in them. So observation does seem to be invariant across all of those definitions, I would say, maybe.
I agree with completely with that as well. And this is an argument I've now had with lots of people, is when does a scientific hypothesis become a scientific theory? And I know that philosophers sort of stare at physicists trying to do pop philosophy anyway, but it is this notion of, when people talk about multiverses as a hypothesis, it might not be 500 years until somebody comes up with a testable hypothesis that makes into a theory. Does that mean that it wasn't science all the time up till then, or you know, it's such an amorphous kind of idea?
And go on.
Sorry, if you're right, Geraint, then absolutely everything came to be science and physics, because any time in the future, who knows, anything might pop up. That doesn't do much to advance the argument. It doesn't help us understand what science is. Science is now anything anybody says about anything, and I don't know how helpful that is.
This is one of the most incredible things about physics, is that it's made so many advances without knowing what it even is.
Can I throw another doozy in there? is physics proving something is or proving something isn't?
Probably neither. I think what it does is it shows that some things do.
Oh, okay. You know, like if someone says, oh, I believe in ghosts, do you say, well, prove to me that ghosts are real? And then they can say back to you, well, prove to me that ghosts are not real.
Yeah, and physics does neither of those things.
Well,
what it does perhaps is demonstrate that there's something out there that does something that looks like a ghost. And I think that's as close as it gets.
I'm not sure that's completely true. I mean, if you think of the Michelson-Morley experiment, that was basically an experiment that was trying to show that a thing didn't exist, the ether, the electromagnetic ether.
Well, it showed that a particular kind of ether didn't exist, but there are other kinds. We now have 27 different types of quantum fields, which are tantamount to something which might be like an ether if you think about it the right way.
Well, right, but the sort of at the time, the nature of that experiment was such that this was supposed to indicate the lack of that kind of ether,
and it did,
showing the absence of something. And likewise, in medical sciences, you're often showing the absence of an effect. If you want to know whether a drug works or not, what you're looking at is that it has an effect or it doesn't have an effect. So maybe in the medical sciences, it's a little bit different to physics. I'm not sure.
So I guess to summarize, physics is what physicists do, but doesn't that just translate the problem to like, who's a physicist? And
so I have an answer to that. A physicist is a person who works in a building that has the word physics across the door.
Yeah, that's what I was going to say.
Yeah, isn't that true? I mean,
and sometimes confused for chemists.
Yeah, well, this is the thing, is that I personally do not know where the boundary between physics and chemistry lies. And I do not know where the boundary between chemistry and biology lies. And I think these boundaries are artificial, set by journals and funding and whatever you were taught at school, etc. But if you're a biophysicist, you clearly need to understand biology and chemistry and physics to do your job. And I think the boundaries themselves are artificial.
So we're back on the spectrum again.
I notice Stephen Durbach is on the call, and he's someone I've worked with at CSIRO. He's a scientist and an artist. So and that's what he does for a living. He's an artist. So that really demonstrates that, the blurring of the boundaries to a very large extent. Yeah, there he is. If you want to jump in, Stephen, please unmute yourself and say so. But no, not compelling you to do that.
To be totally honest, I just ran upstairs to put my son to bed, and I walked in here and I just heard Stephen Durbach.
Been put on the spot.
Yeah, that's the most on the spot I think I've ever been put in. Yeah, so I did. Unfortunately missed a little bit before it, but
it was we were discussing that physicists, physics is what physicists do, and then I asked who's a physicist then, and then the physicist was defined as somebody who works in a building with physics on the front. And it was about boundaries, and I was just saying that you have an interesting role in that your work crosses boundaries between art and science.
Yeah, well, I'm really interested in how how I guess art can loosen or interrogate boundaries. Actually, like the one thing I really became fascinated by when I had these conversations with a whole lot of physicists and other scientists or actually artists, is they tend to hover over the ideas of physics and interrogate what those even mean. So whereas physicists might measure, and artists will come along and say, well, what does it mean to measure? What is the so they kind of about the context of that, whereas I think physics deal with a lot with content. So it's quite interesting in this conversation. It's almost like we're trying to get to the context, and that that I feel is like something that art can do, and maybe philosophy as well. So yeah, thank you for this opportunity to chime in.
And thank you for attending tonight. Thank you for that. I forgot to run the poll that I kick off at the beginning, so I'll run that now. As And I'll pose another question as we do that. We've failed quite miserably to define what physics is. Can we start from the other end and say what it isn't? Is there anything that isn't physics?
I would say, why not compare it to biology? In biology, it more of the traditional levels, not at the biophysics level. So I'm thinking of what Robert May used to say about population biology, because he, as you know, he was a very famous physicist who became a very famous zoologist without actually touching an animal. And he, up until the 1970s, the mathematics that was involved in biology was pretty kind of tame. And he would always say, well, biology up until this time has been very descriptive. And that's a very good way of looking at things, you see, because a lot of it was you took an animal that existed and you went and discovered, you know, all of its properties, you know. So, but there were so many little odd things. And if you went on to if you imagined you could go to another planet, then you'd find a whole, you know, menagerie of another planet that had life. You know, you'd be describing things, you see, what their behavior is and things. And that's still science, but not quite physics. Because physics, you're actually wanting to get to the really basic principles of things. You want to make, because I don't like using the word laws, because the laws in science are descriptive things. Like, I mean, you describe the law, and because you can't break the law, right? Whereas laws in humanity are prescriptive. You know, you can go out and break it if you want. So I like to think of them as principles, really. You're wanting to look for the very general principles that will happen, that will work here on Earth, and it will work if you were on the other side of the universe, sort of thing. In other words, the most general principles possible. Now, that, of course, creeps up into all the other topics like chemistry and biophysics and things, because you're wanting to look not on the other side of the Earth, but you want to look down to the very tiny things that you can't see very well. And you want to know what the general principles are. So that's where I would think that I would move some sciences away from physics. Thank you to Robert May, famous Sydney University theoretical physicist.
So can I jump in there? So I remember when I was a graduate student, one of the messages I got from Martin Rees is that the important thing to remember about physics is that we only deal with the simple things, that a star is much simpler than a bee. And physicists don't study bees because it's just too hard. That's why we let the biologists do it, right? And you have some sort of overview rather than trying to do the mathematics of bees. And so you're right. I think, you know, physics tries to deal with all the little tiny bits at the bottom. And we try and say anything that's too complicated, we'll give that away to somebody else. But of course, you know, most physics still has this, well, I won't say most, many physicists still have this reductionist idea, is that you can boil a bee down into its fundamental interactions at some level. And you could do that to anything, to a giraffe, to the world, to anything else in the universe. And so at some level, you would say that everything is physics if we could just do the calculations. Right? If we could just do the sums, it's all physics, but eventually the sums become too hard. But you then just hit a fuzzy boundary again, right? Because being able to do the sums is something that changes over time. Right? What used to be impossible 100 years ago, we now do on a supercomputer, and who knows what we will do in the future. Does that mean everything becomes physics? Will we have the physics of bees in the future?
So is there anything that's not physics then?
Well, I mean, what people usually say is that physics doesn't deal with the meaning of things. It deals with the how of things rather than the why of things. So you can't really imagine, you know, a theory of physics coming up with an explanation for why there's existence, or for the meaning of life, or something like that. I think that's reasonably fair. I mean, Lawrence Krauss had a go, but he failed miserably. John Wheeler physicist John Wheeler spent the last part of his life trying to find physics explanations for why existence rather than no existence. And he ended up realizing that you have to leave physics, and he tried to go into logic, propositional logic, and then he realized you can't use that either, and you need to go into something a bit deeper still. And he ended up with this idea that humans, he ended up basically violating what we think of as a scientific principle, Copernicus's principle, that humans aren't that special, and ended up saying humans are the most special thing because their observations are what gives objective reality to the universe.
Yeah, and I think Warren also just put something in the chat there about, you know, physicists don't really deal with ethics or with consciousness. You know, what makes somebody behave in this way? You know, is it behavior that is not physics?
Yeah, I think probably on that, Geraint's point could possibly be rerun, and you could just say, look, it's the complexity. As soon as we can figure out exactly what the neurons are doing, exactly how everyone is firing, and we can even replicate the brains and replicate the processes and replicate ethical behaviors and thoughts, then we can pretty much say we've understood it. So I'm not completely sure it's completely out of bounds.
It reminds me of Douglas Adams, The Hitchhiker's Guide to the Galaxy, when they switched deep thought on, and it deduced the existence of rice pudding from first principles.
Yeah, sorry, I just want to clarify there. I think the philosophical point of view that I was trying to put forward there was you can't go from what is to what should be. So whilst physics might get into the realms of behavior or consciousness and explain it, it can never. I don't know if it'll ever be physics's place to say, well, how should things be?
No, that's probably right.
Because it's a value kind of judgment that you're making.
And how it should be is probably how somebody, perhaps you or I, want it to be.
Great.
How we want it to be may be explained by one day through biology or psychology or neuroscience or something, eventually down to some sort of physics. All I have to do is solve the equation with 100 trillion synapses and I can answer what my brain's doing. So we may be able to work that out and say, well, that's why I want it to be a particular way. But even that doesn't tell you why it should be that way. It just tells you that's why people want it.
Well, could you calculate what is?
Well, should be. There's no should out there in the world.
Well, I guess it depends on. I mean, would physics ever be able to calculate what is good and what's bad?
No, because they are value judgments. Again, that is good for what and good for whom.
Precisely.
Yeah, I don't know. I'm just going to a bit of devil's advocate here. So obviously, a lot of it depends on your view of morality, whether you believe in objective morals. If you don't, then you could quite reasonably say that because right and wrong and good and bad are norms in a society, as long as you can generate that society from physics, right, through biology, chemistry and biology into neuroscience, we know that there's a neuroscientific basis for social behaviors, for example. So if you can start stitching a story together from that, then you could say how norms come about, because the societies that didn't have normative behavior died. If they didn't have a notion of good and bad, it's kind of sort of the social contract, then those things didn't survive. So you can sort of give an emergent story. You can imagine the possibility of an emergent story, I think.
Yeah, but Dean, that will tell us how it is, and it'll tell us perhaps how it came to be that way. It won't tell us how it ought to be. The point, ought is there, is it?
No, the point is, it depends how you interpret right and wrong and ought. If you're an anti-realist about morals and you just think that they're behaviors, social contracts in a society, then there's no problem. You've described everything that needs to be described. It's only if you're a realist about morals and good and bad and right and wrong that you wouldn't be able to explain it, I think.
May I chime in for a layman view?
Sure, go for it.
Oh yeah, I'm not a physicist. I study physics in undergraduate, and I'm IT in my field. I have read quite a bit in the science and philosophy and that. But the most obvious thing that something not physics that I would like to put forward that everyone will find ridiculously simple and known is the astrology. I have seen people calculating in Mathematica model and on, yes, and they predict and everything. But that's obviously every one of us know that's not physics, and that's actually not even science. So that's a very good model when you ask for something not physics. I thought that's one got all the characteristic of science, supposed to be looking at a person and get some number and put into number. So there is some, I was just, no, with due respect, I was just thinking in that field, what has gone wrong with this astrology? And what is the difference that when we talk about the string theory, yes, which is one day we might find something, but that is the hope that we might be able to prove something. But for the meantime, I'm pretty sure it is based on solid mathematics with consistently built model. So yes, I thought that was funny. Sorry, I may just put myself to mute here.
Yeah, no, you've raised a really interesting point there about astrology. I would put astrology in the securely in the basket of pseudoscience. Not science as, you know, I do it as an experimental physicist, but as pseudoscience. So if I was to then add a definition of what's the difference between pseudoscience and science, I find that with pseudoscience, it's looking for evidence to support what's been claimed. So I don't know how many of you would have opened the newspaper, found your star sign and read all about, you know, oh, today you are going to come into some good luck. And suddenly you read into it what you want to read into it. Oh, I found my lost sock. Oh, that was my good luck. You know, so you look for evidence that supports these claims, whereas science and looking at hypotheses is looking at ways that you can negate your hypotheses, looking for ways that you might prove your theories false. So science versus pseudoscience. What do you think, Geraint? You've got your hand up.
Oh, yeah. Look, I was just going to add that, look, I think astrology has been very important to modern science because modern astronomy grew out of astrology, right? People wanted to know where the planets were going to be to make astronomical predictions. So there is, by studying the motions of the planets, we came up with the mathematical rules that told us where planets were going to be. And, you know, Newton gave us his law of gravity, which led to Einstein and theory of relativity, etc. So in terms of mathematical basis, it's wonderful, right? We learned where planets are going to be on the sky from this notion that where they are on the sky is important to us here on Earth. But what we've discovered after that is that if you then try to turn that around and say, does where the planets are on the sky actually influence us here on Earth, that all of the experiments people have done by looking at horoscopes and what have happened to people have realized that those predictions aren't borne out. So it's got a mathematical basis in the sense that we can use rules to say where the planets are going to be. But the second part about that, it then can tell us how that influences people on Earth falls apart. So that, I think that's the part where the scientific aspect of astrology falls apart.
Maybe what we can say about pseudoscience is that pseudoscience is the appeal to evidence, to false evidence, to evidence that is claimed that something is evidence for a theory, but in fact is not evidence at all. And when that claim is made falsely, then the claim is pseudoscientific. Perhaps that's a way of defining it.
Like the anti-vax movement.
Yeah.
Go on,
I
Dave.
remember when I was teaching HPS, we had to do the topic of science and pseudoscience, and you talk about astrology because everyone knows something about it. And I talked about that and other sorts of pseudosciences. And then at the end, I said, now look, you might think that this is all over there, and it's nobody has anyone with any sense has nothing to do with it. But I'll tell you something, that one subject that you would think is maybe scientific, but has a lot of pseudoscience in it and affects us every day, is economics, right? The world economic system, you can, when you speak to people that, you know, financial dealers and things like that, they have all these odd ideas. A lot of them are completely unscientific and substantiated by any evidence. And at the end of the lecture, a girl came up to me and she said, and she was rolling her eyes and she said, you know, my father runs an investment company. And then she rolled her eyes like she was so embarrassed by her father. And she said, and he advises his, he does his trading by astrology.
Has he made lots of money?
That's right. And how unethical, hey? That you take other people's money and you invest it and you use astrology to do the predictions.
Ronald Reagan had an astrologer.
Yes.
So his wife did, and they didn't take too much notice of it. I don't think it's a more of a myth than it's bigger than it actually was. I heard. Yeah. The other one is that the government of Burma spent billions of dollars moving the capital city from Rangoon to the other place in the jungle, based on an astrological prediction. So they actually moved on a certain day at a certain time. So this poor country they just spent billions of dollars to Naypyidaw is the place. And they mowed down all these trees in the forest to put the new capital. And it was an absolute, it was travesty.
Well, Christchurch has its own wizard.
When it comes to investing in the stock market, Peter, it may well be that astrology is as good a strategy as any.
There's a famous quote by Newton. So, you know, Isaac Newton got caught up in the South Seas bubble, the tulip bubble, and lost a lot of money in that. And famously said, there's one thing that I can calculate the motions of the planets and the stars in the heavens, but I can't calculate the madness of men. That's something that's out of physics. Physics' reach.
Okay, before we move on, we haven't used the word metaphysics very much so far, and it's in the title. So, where is that a well-defined term, or does it rely on physics too much?
It's probably no better defined than the word physics, because if it is something that's metaphysics, it is that which is beyond physics. So how far you push physics then pushes metaphysics that much further back. But
based on what we've said, though, isn't it an empty set? I mean,
well,
is there metaphysics? If everything is physics, then metaphysics is nothing.
Well, maybe. I mean, the difference is, I mean, we were talking about things above physics. Usually when people talk about physics, they mean metaphysics, they mean below physics. They mean sort of deeper structures lying underneath physics. So, you know, physics, something like general relativity or special relativity, will rely on a particular notion of space-time. It will say space-time has these kind of properties. There's causality, which behaves like this. Matter behaves like this. Metaphysics will go underneath that and look at it as a subject matter. So it will say, well, what exactly is space-time according to this theory? What does it say about causality and causation? What does it say about the nature of matter? Is there just one view that we can take on this theory, or can we interpret it in different ways? So I would say that metaphysics is, I mean, the way Aristotle, this word comes from Aristotle, of course. He had his physics and then he had his metaphysics. And lots of people say that that's because he meant that you have to do physics, you have to do your physics first and then you do your metaphysics. Metaphysics is a bit more engaged and serious than the physics. So you need a bit more skill in order to do that. And the reason is because you're looking at physics from an outside perspective. That's how I would put it. And you're dealing with categories, the kind of categories that physicists and scientists deal with on a daily basis, but they don't scrutinize.
Yeah, the foundational principles of physics can't, by definition, on pain of circularity, can't be defined by physics. So the way you bootstrap physics, I think, is that you have to do some conceptual work at the bottom where you define certain things in terms of which you then do physics. So metaphysics, I think, is, as Dean says, is below or beyond physics or before physics rather than beyond or after physics. So I think there's actually, I think, a bit of a turf war going on, because logic, for example, is a metaphysics. It's a metaphysical idea. You don't go out and do experimental work and discover logic or prove logic or build logic. But what I find is that physicists, when they do their hypothesizing and theorizing and so on, they think they're doing physics. Whereas, in fact, if a philosopher looks at what they're doing, a philosopher will think they're doing metaphysics, because they're doing logic and theorizing and then doing things that aren't part of the reaction with the physical world. So there's a bit of a definitional disagreement here. Yes, Geraint.
I'm just going to note again is that one thing that pisses physicists off no end is when a philosopher tells them they're not doing physics.
Yeah, of course. Yeah.
So again, you know, I think physics is what physicists do, and the boundaries between physics and metaphysics, etc., I think are very fluffy things and depend upon who you talk to, right?
Yeah, and hence the turf war. That's right. Hence the disagreement, because philosophers think that you're doing philosophy and the physicists like you think that you're doing physics, and I can understand it from both sides.
I think Geraint's right. I mean, there's a very, especially in recent physics, where we've got things like experimental metaphysics. But even if you go further back, I mean, it was natural philosophy until very, very recently.
Mm.
You know, like who was it? Was it Kelvin or something? Who was, you know, these were professors of natural philosophy, not professors of physics. So even at the beginnings of the last century, we were still using those. And it goes back to this business of how we carve the specialities up into biology and chemistry. The point is, it's just too hard for anybody to know everything now. People say Poincaré, you know, the French guy who almost invented special relativity, was the last person who knew everything. And beyond that, it's hard to know everything these days. So you have to split, you know, have a division of labor, basically. And even in the early days of last century, we had philosopher scientists, right? They would call themselves philosopher scientists. Einstein, Bohr, Mach, Boltzmann, Heisenberg wrote philosophy of physics textbooks. All of these guys there was no boundary there, as Geraint says. I think he's quite right on that.
But that raises another topic that we thought we might touch on, and that's how the discipline has changed over the years. Those people back in the day, we've talked a little bit about the lone genius, whereas science these days is not about having enough wealth and time on your hands and genius to decide what you do yourself. You have to go and persuade a committee to give you money to do science. So how has it changed over the years, and does it really matter? Is it constraining what we do, or, you know, and are we poorer or richer as a result of that?
Okay, so nobody else is speaking. I think we're a little bit poorer for it. I mean, the thing about the lone genius is that they can be a bit more courageous, and they can say what they think a little bit more, because they're not constrained by, for example, you know, the disapproval of the community or their employers or the granting agencies. So they can be a little bit braver and a little bit more out there. And obviously Einstein was probably so brave because he wasn't teaching. He could think about this thing, and he was pursuing his own path. So I don't know many people like this anymore. I know of one who is this guy, Julian Barber, who works on quantum gravity. He very consciously left a position at Oxford University, because he wanted precisely that, to be able to focus on his research without being distracted by what was expected of him by the university. So he ended up translating books into Russian and writing these books about time and quantum gravity. But I will point out that even his work still has to face the community, and he still actually collaborates with people who are connected to a university. So he's not completely lone genius figure in that sense.
And I'm going to add to that as well, is that Einstein was also not really a lone genius, right? He was He was a known quantity and he wanted in. So, you know, he ended up in a patent office because he couldn't get into a university, but that was his goal, was to get into a university. So, and he knew the system. He knew that he had to write scientific papers and publish, and absolutely, of course, 1905 was a very different year to the rest of science, but it wasn't like I mean, sometimes he is portrayed as almost like, you know, Stan the plumber who knew nothing about science, who came up with this revolutionary idea, but he was a physicist who ended up in a patent office, not just a patent clerk who changed the world. And I think that story gets a little bit mixed up in the public mind about exactly what Einstein was.
Yeah, I mean, one thing to say on that though is it's still quite surprising that, given the absurdly revolutionary character of the papers he was producing from that patent office, that they got taken seriously. Now, if we were to translate that into the modern times, can you imagine somebody, even if they had a PhD in physics, who didn't make it into academia, who was presenting, as you know, you get these emails as I do, completely world-breaking theories? It's just not going to be taken. It would be probably just buried in the present climate, I would think, because we get too much. There's just too much.
But again,
we had an example of that last month when a gentleman with a PhD in physics, a gentleman called Peter Lamb, came on and tried to tell us about some revolutionary idea of how the world works.
What if he's right?
well, I actually, is he here tonight? I had to look at some of his work. But again, Einstein, he wrote scientific papers that appeared in scientific journals. Yeah. So, you know, he was playing the game by the rules, right? And the rules may have evolved slightly, but that was the rule, right? He wanted to get into a university, and he knew that some level that's what he needed to do. So it's not like he had to email in 1905 professors with, this is my wacky idea about the speed of light kind of thing. He wrote papers which other scientists read, and there was this appreciation. And I definitely agree that he changed everything, but he was still playing by the rules of the day at some level.
Steve, you were going to say something.
Yeah, I was just wondering where someone like Stephen Wolfram fits into this, because, you know, he was a practicing physicist and then he went into computer science and now claims to be rediscovering, recapitulating physics, what you would call, I guess, conventional, the field of physics, through his computational rules, his universes that he's creating. Where does he fit into the story of physics, meta and physics?
Well, I mean, the case of Stephen Wolfram, he was a very highly trained physicist again, so he's gone through the system. He's already had papers published before he decided to set up go and design Mathematica. Even that is a sort of piece of, it could be taken as a piece of academic scholarship almost, the production of Mathematica. So I think he's pretty much more of an academic and a physicist, and yeah, I think he would qualify quite easily, even though his theories are.
But then, Dean, is his model of the world, which he somehow conjures up out of his iterations, his iterative systems, can that be regarded as physics? Is he doing physics when he builds these models?
Well, look, I think this is one of the things I wanted to say earlier. When you're independent like this is why it's good to have people like this, because when you're independent, you don't have to worry. You either get it through wealth, he got it through his Mathematica program, or maybe a Nobel Prize like Brian Josephson or Geraint at Tufts. They pursue completely out there research, and it might be completely bonkers, but it's probably going to throw up a few interesting little bits here and there as well. I don't know enough about Wolfram's work. I mean, it sounds like he's just doing the usual sort of building things up from complexity, digital physics things that have been done by a bunch of other people, but a bit more systematically.
Yes, he's starting from something like a game of life and trying to build the universe out of it.
Can I just jump in? I listened to a podcast recently with Stephen Wolfram and also Eric Weinstein, who is also, he's an outsider. He's I think he physics trained, but is now in finance. And is also somebody who's proposed a theory of everything based upon a different set of mathematics. And it was a very interesting podcast because they were both basically shouting at each other about whose theory was the simplest and easiest to understand. And the bizarre thing in my mind as a physicist listening to it is that no physicist cares about what these guys are saying, because they are not proposing theories that can be tested, right? They haven't written papers about this is how you see if my theory is correct. So they are doing something, they're churning mathematics. But it's a part of physics, but it doesn't quite, do that last part of doing this is the observation that will tell you that my mathematics is the correct mathematics.
I would say that in those cases, I don't know about Weinstein's theory. In the case of something like Wolfram's, the test is supposed to be the ability to reproduce physics, a unified theory where you've got general relativity and gravity and all the other bits, just to be able to reproduce it in one single theory. I mean, you might compare it to something like the ensemble, the multiverse theories, right? We've got a puzzle, an observation. It's not telling us new things. It's trying to explain why we see these known things, right? Why do we see these particular constants? Well, because we'll postulate this thing here. So I think he's doing something like that. Let's postulate a model and see if we can replicate what we actually observe, even though he's not producing anything testable because it's based on everything we know already. I don't think it should necessarily be dismissed.
No. I'm not. Okay, I'll wind back slightly. I think at the moment, though, the situation is that the mathematics looks a little bit like modern physics rather than it can reproduce modern physics. I think that's the situation they're in. Yeah. But it's not sold that way when you like read the ingredients on the tin. It's sort of like, this is the theory that solves it all.
Yeah.
Dean, is there anything in the hypothesizing of different models which is out of bounds, or is everything up for grabs? You can make up whatever hypothesis you like, and then so long as it replicates physics, well, then you're okay.
You say that as if it's easy to do that.
No, it's not, I know.
Yeah,
but I'm just wondering if there are limits to what you can do.
I mean, well, look, so far we don't have even one consistent model that successfully unifies general relativity and quantum gravity and the other forces. You might say string theory does. There's dispute about whether it achieves what it's supposed to achieve. So, and even if that's true, that's just one model. So it's incredibly hard to find models that do this. That's why I think anything that claims to be able to do it, if it's even close, it sort of should be given a little bit of attention. It shouldn't be dismissed, that's for sure.
Now, maybe I should qualify the question a little bit. Is there any way of narrowing the field, of looking at something and say, no, that's never going to work? Or are we really in a position where we have no idea and anything at all might be the answer, that we might come up with a model from completely left of field? Can we apply what we already know about the world to narrow the field in which we look for a unification theory, say?
Oh yeah, I mean, that's exactly what happens, right? It has to produce the low energy physics that we actually see. Otherwise it's toast. Otherwise you can't do anything with it. So it has to have the gauge interactions. It has to have the constants with the right values and these kinds of things. It has to have 4 space-time dimensions that we can see at low energies, whole bunch of constraints. It's massively constrained. That's the problem. That's why it's so hard to get this thing, get the theory that does it.
Look, some of the people that we talk about, aren't they more, and dare I say it, engineers rather than some of these mavericks? So in history, let me think, people like Charles Babbage, Oliver Heaviside, the real Nikola Tesla, not the UFO one, right? And then later on, the Gaia man, James Lovelock. And then I would add Jay Forrester, the person who did all the world dynamics modeling. He was an electrical engineer. They're all kind of solo people. Wolfram and Kurzweil and all these are physicists, yes, but they're also kind of like engineers as well. So there's a kind of and Buckminster Fuller is another one, right? So they're all kind of in between academic science and the commercial kind of engineering as well. Maybe Shannon as well, because he worked for Bell or whatever.
I'm just going to say there's a very thin line between physicists and engineers as well.
Yeah.
There is, and I dare say that I'm an engineer, Geraint. I've never wanted to admit it in front of you because I know you get so many letters from, but I did do physics and I did philosophy, yeah. I did physics with, my third year was with Hanbury Brown and Bernie Mills. So there's a little bit of history there.
I mean, what's interesting about those people that you mention is that often their particular specialty will infect their view of the universe or whatever it is that they're trying to describe. So they will, you know, you mentioned Shannon, you could say there's a guy called David Finkelstein as well. All of these people are sort of computer programmers or they sort of coders, and then their version of the universe or physics becomes code, essentially, becomes a digital problem.
Right. I've met Finkelstein at a conference once. He came to a Whiteheadian conference along with Geoffrey Chew. How's that? So a lot of physicists, more than other scientists, are attracted to philosophy and particularly metaphysics, I find. Do you find that?
Mm-hmm. Yeah, definitely.
So yeah, on that subject, Dean mentioned Brian Josephson, who you know very famously now got the Nobel Prize for the Josephson Junction back in the 70s. But since then, he's as Dean said, he's used his academic freedom. I mean, which committee is going to say no to a Nobel Prize winner? And he's explored things like psychokinesis and telepathy and memory of water. In the time we've got left, I'd really like to explore those things that are really out there, and you know, are there areas in there which have merit to research, or are there things that we should be looking at that would be fun and advance human knowledge, rather than sort of working out the magnetic properties of some thin film?
I think you should always leave like a crack of the door open, just a little bit, to absolutely anything and everything, actually, because, you know, like so many of the theories we have now, so many of the bits of knowledge we have now were completely out there at one point, like quantum entanglement and the delayed choice experiment, where you're sort of setting what happened in the past like now, and it's almost like a kind of retro causality, electromagnetic phenomena and things like that. So many things looked out there. So even though they're completely bonkers, the things, a lot of the things Josephson looks at, I think it's still good to have people who are just poking those problems, any and all problems, a little bit, just in case.
And I suppose that you do need somebody like a Nobel laureate to add credence to those topics. You know, if it was, you know, the engineer from down the street who keeps emailing us his theories, who said, well, I'm going to start researching memory of water, he'd be laughed out of the stadium immediately, right?
Yeah.
Yeah, it always surprises me that you know, how many people who come forwards to me and my colleagues, you know, won't accept that the conservation of energy. Oh, we actually debunked that in the last meeting anyway. But they you know, the number of people that come forwards with machines that have over unity is just incredible.
So I completely agree with Dean here, is that, look, all good scientists should have a tiny non-zero probability for just about anything somebody puts forward, right? I mean, we as scientists, we shouldn't be setting all probabilities to zero, because then we are just, you know, as bad as everybody else, saying that that is definitely not true. But then anybody who's proposing something has to be willing to have it subjected to scientific hypothesis and testing and all the rest of it. So I think any person should be happy enough to rock up to Scott with their, over Unity machine and willing to have it tested, right? And we already know that it's not going to work, but as long as the person accepts that the science has showed that their device hasn't worked, then I think we're doing the right kind of thing. The problem we have, of course, is we're constrained by time and money and all the other things that we can't do all of this kind of stuff. But I think people should be able to propose things, and we should be able to either point to evidence and say, that's why it doesn't work, or do an experiment to show it.
That damages the public image of science to some extent. You're right, Geraint. We are constrained by money and resources and so on. And we can't spend, physicists and scientists can't spend all their time debunking theories that have been debunked 1,000 times before. But presenting to the public a dismissive attitude to those things that have been debunked before, and being short with the general public does tend to make the general public think that scientists are somehow elitist or arrogant or something. And it doesn't do science any favors. And I don't know how to answer that. I don't know how to counter that. But that is a problem.
But in what sense, right? I mean, I personally, I deal with a lot of emails from people that propose alternative cosmologies, etc., and I go through about why their stuff doesn't work. I give them a lot more time than they ever give me, kind of thing, right? And they don't offer to pay me for my time. I mean, what does he mean by being short with people? I mean, I am not funded to be a public scientist. I am paid by the university to teach and do research, and what they get is me in my spare time. And if I am short with them in my spare time, then that's their lookout, isn't it?
No, you're much more generous than many. And I think the point is the others and not you. There are people who are far too dismissive. There are people who don't leave that little crack open. And they dismiss ideas far too quickly for the likings of the people who put the ideas up. So I think there's a bit of a problem there.
I remember when Brian Josephson came to talk in Australia the last time, and there was a lot of controversy in the AIP as to whether we would sort of get behind and support his talk. So yeah, it's very difficult to know where to draw the line. I've shared the poll responses here. A lot of people have said yes to consciousness. I guess that's probably not very mystical, and we've all got an interest in that one. Anyone want to talk about why they put yes in any of these?
I'd like to share. It's Leonie. I have a basic physics degree, a little bit of extra studies in astrophysics, and I'm a trainer. Stuff that we've been doing with artificial intelligence could easily be the province of physics and a proper exploration of how we can connect better with people using data and actually reading it really, really carefully. For me, I see enormous similarities with the uniqueness of how the mind moves and some of our greatest unyet explored ideas. And for me, it's an area where we could make a difference. And it definitely has made a difference in how I present courses and how I keep options open for people to think outside of the box. And many people cannot do that. And I think we could enhance trainers a lot. But that's just my thoughts.
Thank you. One thing, I'll there's a pause there, so I'm going to interject something I'm actually quite interested in, and that is, I mentioned ghosts before, and I come from a family that reckon they've seen them. I've never seen one. I've always found it fascinating, but to me, if anyone asked me, do you believe in ghosts, I'd say no. But I'm only one sighting away from saying yes. So I'm just wondering, we're all probably very, we try to be objective here. Has anyone had an experience that they can't explain?
If no one else is going to answer, let me throw that back at you, Scott, to something I said earlier in the evening. What observation would prove to you that you had seen a ghost? What observation would you not stop and go, oh, actually, the wind was blowing the curtain, it's not a ghost, or some such?
All right, I'll tell you why you know, I have an interest in this. My grandparents used to own a hotel in a small town in Cornwall. My family used to go there and work, and instead of having and if they had a big thing on in the evening, they would take me and my sisters there and put us up in a spare room and have the receptionist keep an eye on us rather than getting a babysitter. And when I was 5 and my sisters were 3 and 2, we went there on that basis in the evening. They put us in this room for the night while the event went on. And apparently the next morning I came, this is what I was told. I have no recollection of it. I was told that I asked if we could have a different room the next day because there was an old lady tucking us in all night. And of course, no one had gone in there. And then they realized that my great grandmother had died in that room. And so my family were going, oh, well, that makes sense, you know. And so, yeah, but they gave us a different room. Now, that they told me that, and they're not trying to sell me a ghost story for the hell of it. Maybe they're putting 2 and 2 together and coming up with 10. I don't know. There's a lot of, is it just coincidence? I don't know. But I think if I was in a room and I did experience an old lady tucking me in all night, and I tried to grab her and my hand went through, that would probably convince me. It depends how much I'd drunk before I'd gone to bed, perhaps.
I think there's an interesting way of dealing with these kinds of phenomena. It's broadly Jungian, actually. So with the case of ghosts and sort of synchronicities where the world seems to be behaving a certain way that matches your interior and things like that, I think you should almost, or poltergeists and things like that, you should almost interpret them as waking dreams and interpret them in exactly the same way as you would a dream, and look at the sort of representations and symbolic factors going on. So you can sort of treat them phenomenologically almost as, oh, there was an experience here. Don't even worry about whether it was made of this or made of that or was your brain, but there's a thing that can be studied still scientifically. You can study the phenomenology of these experiences in people. And you could do that scientifically and then see what kind of patterns you come up with and trace it maybe to some features of the brain. Maybe you're having sort of waking dreams and projecting things out onto the world. So
that would be single experiences, but when you get 2 different people who are completely unrelated, who have the similar kind of, let's say, a ghost experience in the same room, and one hasn't communicated, that's when it's not just one person's brain, but the other person's brain has coincidentally come up with the same thing. And I'm thinking of, and if we want to be really scientific here, at Sydney University, in the biology department, they've had a long history of a single ghost of somebody who died maybe in the 1940s or something. And there has been several totally independent people who have reported a very unusual thing. One was an electrician who'd just been called in to do a job after hours, and one was a young student who was told to look after some animal things for something, and they had no idea that this story existed. And then everyone said, oh, you've just seen the ghost of so-and-so, as a kind of joke. But so that when you get common experiences, I think that's when the myths sort of keep going.
Well, you raise a very valid point there, Peter. In fact, I was just about to say something similar when you jumped in there, that as soon as you how do we determine whether our scientific results are robust? Well, if they're repeatable and reproducible, you publish your results. If no one can reproduce them, then maybe your original results were wrong, right? So yeah, like you say, if you've got a lot of different people who've observed similar or the same thing without knowledge of it beforehand, and I think that's key. Is that scientific proof?
Yeah, I think sometimes when we look for scientific proof, we're really looking at whether something exists or not. And when you're talking about existence, you're talking about reality. And in my mind, I like to think of reality in many different layers. So I like to think about a base reality, which is kind of that reality which may or may not exist, and is the reality which we would see in the Matrix, or you know, it's that kind of base reality that's unreachable unless you break out of an objective reality that we experience. And then I think above that, there's an objective reality, which we have to assume is the reality we can actually measure, or we're trying to measure, we're trying to reach it. And then I think there's a communal reality in which things like money and countries and these kinds of things exist. They are realities which don't exist in a physical reality or a physical form, but it's by our convention that they exist and have real consequence in the physical reality, I guess. And then finally, I mean, there's our subjective realities, which exist only in our minds. So when we talk about does ghosts exist, in which one of those realities are we talking about? Because they certainly can exist in our subjective reality, and nobody can argue with that. But certainly we can dispute that whether or not they exist in an objective reality.
I'm just going to add here. Look, so to Scott's last poll, I said yes about something I can't explain. In fact, there's lots of the world I can't explain. And as a physicist, I think I would be arrogant if I went around saying I could explain everything I see. But I'm not impressed by ghosts. I can completely understand. I mean, I'm sure most people have heard of ghosts before they've ever seen a ghost, right? I mean, I saw ghosts on Laurel and Hardy when I was a tiny child. But there have been weird things that have happened to me that I struggle to understand. And one of these is going to sound so trivial, in that I lived in this house and I opened my wardrobe one day and a bird hopped out of the wardrobe. And I still don't understand how that bird got in there, etc. That kind of thing freaks me out. And I'm sure that there is a physical explanation. But that's the kind of thing to me, which is more weird than people seeing ghosts or something related to when they were asleep or had too many pints when they came up from the pub or were driving through rural America and saw lights in the sky kind of thing. So, you know, there are things I can't explain, but it's not something to do with ghosts.
Adding to that, I think just everyday reality is enough for me. I can't explain that, why there's everyday reality. Just any experience of anything puzzles me to hell. I just walk around in a constant state of puzzlement, basically.
Like a true philosopher.
Yeah.
A physicist friend of mine and I were walking through the country, in Surrey, back when we were students, and it was a very quiet, windless, sunny day, and we were walking along a country lane, and a bunch of raw sausages just fell out of the sky and hit the road in front. And the first thing we do as good scientists is like check the engine noises, nothing. And I reminded him of this about a year ago, and I said, "You remember that? I just remembered it." And I go, "We did see that, didn't we?" And he goes, "Yes, we did." And we couldn't. And that's the weirdest thing. We have no idea where those sausages came from. And if it was just me there, I would have just put it down to being crazy. But there was somebody there to back me up. So
I'm going to suggest it was a very strong bird.
I think that's probably what it was. But
it's actually
a lot of sausages for a bird, though.
It's actual proof that we're living in the Matrix. That was a glitch.
Well, I don't know. I think that might be a good place. Falling sausages might be a good place to end it for the evening. Can anyone beat falling sausages?
It's hard to top that one.
Okay, well, thank you, everyone. This has been a really enjoyable discussion. Thank you, Tibor, Kirrily, and Geraint, as usual, and really thank you, Dean, for joining us tonight and contributing so fully, and to everyone else who's been here tonight. I think it's been fantastic. Let me just say that next month is our last Zoom into Physics for this year. And it's still in formulation at the moment. We're going to do something with a physics in about Christmas type of theme. So probably a little bit of fun, maybe estimating sort of, the speed of Santa and that sort of thing. And so look out for that one. And I will process this one and put it up on YouTube. We're getting quite a good strike rate with YouTube these days. So a good following, and thank you all for coming tonight. Really appreciate your time, and have a good evening.
And thank you, Scott.
Yes, thank you.
Thank you, everybody.
Thanks,
Thank you.
everybody.